Hello everybody and welcome to this demo session about Ansible and Terraform on hosted private cloud. My name is Yann Lamoureux. I'm solution architect at OVH Cloud. I'm sure you already heard about infrastructure as code and more often on some of the tools which are used on this context, like Puppet, Chef, Ansible, and Terraform. Today, let's focus on both of these, Ansible and Terraform. First, a short recap on these two tools. Terraform is agentless, meaning it do not require to install anything on resources you want to manage, and it's only used on available API. Stateful, it means it keeps a status on deploy resources and is able to compute the difference and apply only required changes. It's based on providers who implement data and resource recreations. All of the core and providers are written in Go. Mean Terraform is cross-platform, can be used on Linux, macOS, and even Windows. On the other side, Ansible is independent. It means it do the same operation each time you run your deployment code. It's agentless. Most of the time, you use SSH to connect to the resource you want to manage. In fact, it is at least based on Python if no API is available. Also, it is stateless, meaning it does not keep any resources or any states of the resources it manages, because as it independent, it tries to apply any action it is planned on your deployment code. Also, it's based on module, and since 2.10 versions, it uses a collision aspects which regroup any modules. All the core modules are written in Python, meaning Ansible can only run now on Linux and macOS. Now let's consider a hosted private cloud platform on which we would like to deploy our awesome new applications. A hosted private cloud is a VMware SDDC stack, with vSphere for the compute, for NSX with NSX for the network, and vSAN for the storage. As OVH Cloud, we provide standard API, we give you direct access to the native API of the product. So vSphere SDK, not well named, but it's the API endpoint for all the resources, and NSX APIs. Now, if you know well Ansible and Terraform, I'm quite sure you notice there is no hosted private cloud module or providers. It's because at OVH Cloud, we do not reinvent the wheel. In both Ansible and Terraform, it exists a VMware integration to deploy workload and manage resources. Let's see how to use them on hosted private cloud. Okay, on the right, we have our SDDC stack. On the left, a shell where we have all the tools. Let's start on Timo 24. Let's start with Ansible. Let's dig into the code. So we use Playbook to deploy our workloads, and on a first resources we would like to deploy, it's to create a folder to host or to regroup all the resources of this demo. So we use a resources or module called vSphere folder. We provide them some value to connect or to consume the API. So the host name, the port, username, password, and aspect about the certificate and data center name. The main important part is a folder name, the kind of folder we would like to deploy, and the famous state presence. Okay, let's see how to deploy a folder. So on the first playbook, we prepare the context of this demo. So we would like to create a VM folders. So for that, we use an existing module provided by the community called vSphere folders. The vSphere folders module needs some information to consume the APIs. So it requires a hostname for the vCenters, the port, username, password, and also a context execution means the data center name. We name the folders and we define which kind of folders we would like to create and the famous states. To give you more information on data we provide, I put on a variable file all the information. So the famous post name, the username demo, the password, and also the context of the execution, mean the data centers, which is present there. Also resource to host the VM, the data stores, and a host to compute for deploying the VMs we will do later. We run only on local host, so all the execution is made on the is done on the main shell, and you will see appear a demo folders. In the next step, we will deploy a VM. So we use the VMware guest modules. We provide also the same information, but we add some different elements, like, for example, the templates used for the cloning. So it's already existing there. If you'd like to know how to create this kind of templates, let's see the demo, how to use Packer on bare metal cloud. We will deploy this VM on the folder we previously created, and we define some hardware configuration about memory, CPU, and also disks. As the VMware guest works, we need to define the network in the second steps, and later power on these VMs. Okay, that's right. I will just expand the folders, and we see on the recent task the different action. We also already see the demo, the Bastion VM appeared. Clone is done, and then switch the different network. So create two networks cards, one for the public one, another one for the private communication with another kind of VMs. And finally, power on the VMs. And it's done. Okay, we have a VM connected on two networks. VM network for the public network and the VLAN 10 for the private communication. On step 2, we would like to create another VMs called DB, for example, for hosting your database engine for the application. And for this, we will try to deploy not a Linux box, but a Windows one. So based on existing templates there with Windows 2019. Also, we do the configuration and we connect them only on VLAN 10. For the Windows VM, all the operation mean network configuration and power on is executed in the same phase, because the VMware integration for Windows VM, it's much more easier, especially for the customization. It supports any kind of Windows, so that's why it power on the VM in the same phase, but it executes all the steps in the same orders. And you wait for the VMware tools returning an IP on the networks. The network's DHCP is provided by an NS6 edges, which is part from the NS6 context. It's just a VM with a DHCP server to be able to provide to serve IP address on VMs connected. Okay, task is done. Next, we'll create a third VM, similar to the first one, but the idea is to deploy Linux boxes, also Debian one, just to after deploy our application and then be able to consume the DB or serve the DB data hosted on the previous created VM. Also, like, because it's Debian boxes, we need to split in 3 operations, the creations, start from the cloning, then changing the network, and after that, power on the VM. We have now 3 boxes, 3 VMs, the Bastion one for the job host to be able to manage the platforms. We have a DB servers, the DNS names, and we have also our front VM boxes, on which we will install later the application and deploy, for example, our website. And it's done for this part of this demo. Before switching to the next part, we need to clean up all what we created. So we use also a playbook called cleanup, where we also use a VM guest. So we call again the same module, but we just change the states to mark it as absence, and we put also the fourth option to force the fact to delete a VM which is power on the security on the module. So we destroy the different VM and then remove the folders. Let's run it. And we will see the different boxes and the folders disappeared. And it's done. So now we are back to the initial situation or status of the platform. We don't have the demo folders, no resources on that. Let's try to repeat all these steps with Terraform. So Terraform has another way to manage and to connect to the resources. First, we define the famous providers we would like to consume. So we have famous providers, so vSphere, on where we put the vCenter, the vSphere vCenter address, the users, and the passwords. We have then some variables used for that, so as we declare the different aspects. And oops, the famous data, where we collect and inherit from all the information. So we define the DC, we also define clusters, the resource vSphere host, the vSphere data stores for knowing and discovered the data store where we deploy the VMs. I also use a sort of interpolation to be able to extrapolate the vSphere digital virtual switch information, and we also collect the public network's name, called VMware networks, and define it. The famous backend we reuse the VM10, and also discover the different templates already present on the infrastructure to be able to deploy VMs based on that. And the most important parts, the fourth, where we create the resources. So first of all, we create the demo folders. Then we will create the Bastion VMs, is again on the clone. We set up the two network interfaces. I also push some extra data or extra configuration to be able, for example, to set up a fixed IP address based on the cloud information. Then again, we create the famous DB VM. Windows boxes we clone. And at the end, we create the front VMs, which is public facing on the internet, also connected to the backend VLANs to be able to communicate with the DB. And I also push some extra configuration to be able to configure the fixed IP address over the cloud init. With Terraform, we need to init our context. So it will collect or find or install the different providers. So we will have the vSphere one, the local one, and then I will plan to see what change will be made on the infrastructure. So we'll take the context, see what's happened, and as we see, we will create 3 resources. So if we look at that, we create multiple boxes, so different fronts and Bastion and so on. Oops. I forgot to change something. I so forget to talk about that. So there is some predefined value. So I would like to create only a first front VM. I define the different templates to be able to extrapolate them, and the data stores, and also the public IP blocks to be able to provide the fixed IP address. Let's discover the change. Okay, now we have 4 resources to add. Let's apply this. Before doing any change, Terraform requires you to confirm the actions, and then version is launched. So we see the demo folders appear just there, and all the action on it, like running the VM, and it does the action in parallel to speed up the process of VM creations. Okay, so all our 3 VMs have been created. We check that VM, we thought that the VM was power on, and the public IP address defined on it. We also have Windows VM boxes with a private IP address on the backend VM, the VM 10, and also the front with the public IP address and a connection with the backend with the private address. Okay, if we ask now, just in a case, we would like to deploy more of front VMs, for example, for scaling the application, we just have to change the front count on the variable files, call auto tvars, and just call again Terraform plan to see what change will be made if we apply like this. So that's what the main difference with Ansible. He has a context execution or context information. So we know that he has to create more resources. So because we have now 2 VMs, I'll configure and plan to configure anti-affinity rules called GRS mods, just to be sure that the 2 front VMs are not hosted on the same compute node, and we will deploy the second VM. Let's apply this new change on the platforms. Again, it will require a confirmation, and then clone again a second VMs, name it front, set up the IP address on it, and also create anti-affinity rules to be sure that the 2 VMs are not hosted on the same host or same IP address. Okay, the second VM has been created. The IP address has been set, and we also configured, if you look on the clusters, we saw the famous anti-affinity rules to separate the VMs and with the 2 VM created on it. So the GRS rules will ensure that both VM are not hosted on the same IP address. Now we finish the Terraform part, and we would like to restore the initial environment, remove all the application or all the deployment. With Terraform, it's quite simple. We just call Terraform destroy. Doing this, we will initiate the context and the states, list all the resources to destroy, so the 6 resources coming from the GRS rule to the 4 boxes. Again, before getting them, we have to confirm the deletion, and we remove all the resources. And so, thank you for joining us for this demo session. We are now available for any question, and we can also reach us on Twitter if you have more questions. Thank you, and have a good day. Bye-bye.